Hello, in today's lecture we're going to be discussing the idea of heat. And so let's first identify what this concept is. So we already know what temperature is. Temperature can be measured in degrees Celsius, degree Fahrenheit, or Kelvin. Heat, some people, especially outside of the sciences, think that heat and temperature are the same thing, but they're not when we're discussing it in the context of chemistry. So heat is actually the transfer of energy from very hot substances to very cold substances. So let's say we have two blocks that are connected, that are touching each other. We have block A and we have block B. And let's say block A is at 32 degrees Celsius and block B is at 74 degrees Celsius. Now, over time, what will happen is this temperature will equilibrate to something in between those two numbers. So let's say over time, A and B will become the same temperature and it'll be somewhere in the middle of this. Let's just say it's going to be 54 degrees Celsius. The reason for this is that the hot substance, the higher temperature substance, is moving faster than the low temperature substance. And these high temperature particles will, since they're touching these low temperature particles, will be transferring energy over to the low temperature particle to try and make them speed up. And so over time, what will happen is these things become the same temperature. Okay? And that transfer of energy is actually what we're going to consider heat. And we're going to give that the letter Q as our variable for what heat is. Now, for heat, we have a very specific equation in general chemistry that we're going to be using. And for substances like this, we're going to be using an equation such that Q is equal to mc delta T. Okay. Q, like I said before, is heat. M is the mass. C is something called specific heat, heat capacity. And delta T, delta in chemistry means change. It means final minus initial. So delta T is going to be T final minus T initial. This is what equation we're going to be using to identify how much heat is either absorbed or given off in a given process. So let's break down what the units are for each of these variables. Q, for this class, we will either use an energy term called a joule, and we denote that a capital J, or a calorie, C-A-L. Those are the two units that we can use when we're talking about heat. Mass, that can be in a lot of different units, generally grams, but you already know how to convert from grams to any of the other mass units, so we can always convert our units if we need to. Specific heat capacity is something special. It's a value that's unique to every substance. So it's a way of identifying substances, but it's also a way of identifying how much heat is needed to raise the temperature of that substance set by a certain amount. So specific heat capacity has units of joules per gram degrees Celsius. Or it also could have units of joules per gram kelvins. So this is two very specific types of units, but they're actually the exact same. Degree Celsius, degree kelvins in this case will end up becoming the same type of unit when we talk about the delta T. Okay, so let's see. Delta T can be in Fahrenheit, degree Fahrenheit, degree Celsius, or kelvins. Usually, since this is in degrees Celsius or kelvins, we're going to be talking about the degrees Celsius or kelvins. Now, when talking about the delta T, the change in degrees Celsius is always going to be the exact same as the change in kelvins. So delta T Celsius is equal to delta T kelvins. Okay. So these units can be either in Celsius, degrees Celsius, or in kelvins. It doesn't really matter as long as we know what the delta T is. So this equation is how we're going to identify how much heat is either absorbed or released to the environment in a given process. And we're going to be looking at this when we have a very specific type of substance. It's a pure substance, and what that means is there's either, like, let's say water, liquid water, it's only in the liquid phase, or it's only in the solid phase, or it's only in the gaseous phase. This equation only works for pure substances, and we'll have a different equation that we can talk about when we have mixed phases. But for right now, we're only going to be dealing with pure phases, so this is the equation that we're going to be using. So this is all I want to discuss about the idea of heat. We'll be working a lot of problems with this concept of heat in the next class. But with that, I want to say have a great night. I'll see you all in class tomorrow.